Now, Kushal Chari, Dean of the Lubar School of Business at University of Wisconsin-Milwaukee, will introduce our speaker.
Good morning. Well, the mysteries of the universe has always intrigued humans for ages. And we still do not know enough about the universe. And in fact, today, the media reported some of the images taken by James Webb Telescope on the supernova. So clearly, these are very exciting times for space exploration. And it's so timely to have Dr. Jean Creighton talk about these exciting things happening in space exploration. So, Dr. Creighton is the daughter of a mathematician and a translator, and she has been fascinated by stars since she was 5 years old. That reminds me of the nursery rhyme, Twinkle, Twinkle, Little Star. Jean obtained her BSc at the University of Athens in Greece, where she grew up, and then moved to Canada for her graduate work. She earned a PhD in astrophysics from the University of Waterloo, where her older son attends now, and went to Caltech to work on infrared satellite. In 1999, she moved from Pasadena to UWM to teach astronomy. In 2007, she became the director of the UWM Planetarium. In 2014, NASA selected her to be one of the airborne astronomy ambassadors, and she spent 20 hours in the stratosphere on SOFIA, the second largest moving observatory in the world after the James Webb Space. I just wonder how it would be like to be in the stratosphere for 20 hours. I would be delighted to learn more about her experiences. In the 15 years since she has been the planetarium director, she is very proud to have shared the beauty and elegance of cosmos with our community. So with that, a very warm Rotary welcome to Dr. Creighton.
I'm doing a second count to just check. Yes, we're good. We're good. Thank you so much for your welcome. It is my pleasure to get to talk about space, since that's what I certainly get jazzed about. I'm sure that you're going to have questions about astronomy that I'm not going to answer, because my topic is fairly specific about exoplanets. But of course, there's going to be time for you to ask questions. So if you have burning astronomical questions, please feel free to ask them at that Q&A time. Since people have been kind enough to ask me, so where is the planetarium? How can I get to see programs? I thought, wouldn't it be clever to show the upcoming programs? Some of them have already taken place, but we do have public programs, many Fridays, some Wednesdays, and our planetarium is on the main UWM campus, and that's at the corner of Kenwood and Kramer. If you would like to, there's a QR code that your phone might be big enough for your phone to see. But if you forget all of the above and you just Google UWM Planetarium, you will get this website and all the ways to buy tickets for programs. Some of our programs are free. Stars and S'mores is a favorite. September 1st, where we get to talk about stargazing and sneak in a goodie as well, which of course is a wonderful combination. So, what is an exoplanet? I have a hand there. Go ahead. Thank you. It is a planet outside our solar system. How many exoplanets have we found so far? Order of magnitude, 10, 1,000, 10,000. 10,000 is high, or we're at the 5,000 mark right now. So there have been many, many exoplanets, And the point of the James Webb Telescope is to help us narrow in to answer this question. The big question, are we alone in the cosmos? I would be curious to know in this room, and there's no correct or incorrect answer, but I'd love to know in this room, take the temperature. Do you think there's life outside the Earth? And if you think yes, please raise your hand. Okay, so many of you think that there should be life out there because then the argument usually goes, well, there's so many planets, so many possibilities. And that's fair. There is, of course, an answer that life took a lot of finessing. It's hard to get those circumstances. But since this is an open question and a deep philosophical need to know, really, truly, are we alone in this very large universe? We are exploring this question. And for a long time, for 50, 60 years, a lot of our efforts went in looking for technosignatures, which is a fancy word of saying we were eavesdropping. We were wondering if we listened carefully, would we hear other signals of civilizations talking? And some of you probably have seen the movie Contact. It's an excellent movie that was talking about how would we know? How would we explore this question? It turns out that in the many years that we've been listening, we have not heard a signal that we could certainly say, yep, that is a signal from some civilization. So subsequently, we decided to look for more primitive, if you will, signs of life. And frankly, the more time passes, the more we think we're more likely to figure out that another planet has some primitive life, some bacteria, something like this, rather than moving, talking, intelligent life. So, how are we looking for other planets? There are more ways than I'm going to present, but I'm going to go for the three top ones. We are going to look for transiting. We're going to look for Doppler shift. In other words, when a star is moving in response to an invisible planet, and what you might expect the normal thing to be, and that is a direct picture. Boom. I'll start with transiting since that's been the most, by far and away, the most fruitful way of looking for a planet. The idea is fairly simple. I was hoping I would have a really bright light source in the room, but I don't have that, so we're going to pretend. This is going to be a sun. This is going to be a planet that goes in front of it. If the planet goes in front of the star, the brightness of the star is going to drop a very small amount. As it turns out, in the last 20 years or so, our cameras are so good that we can measure this reduction of the brightness of the star, and it looks something like this. So when the invisible star comes in front of, when the invisible planet comes in front of the star, we see a reduction in brightness, and from that reduction, we can figure out how big, literally, what was the diameter of that planet that went in front of it. Is this making sense, or is this sounding like I didn't get enough coffee this morning? Okay, thank you. So this is what we call transit, and the first telescope that did this big time was called Kepler. And in honor of Kepler, it found more than 2,600 exoplanets. It looked in all parts of some parts of the sky, but it zoomed in to a particular portion of the sky in the constellation of Cygnus, which is visible today now. And the little doodads that you see here are individual systems. In some cases, it's only one exoplanet per star, but in some cases, it's multiple. And those of you who are very careful observers, you'll see a pizza slice of sky in the lower left side that has many, 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 many little doodads. And that's because that was the deep section of sky that Kepler parked itself over many nights. And then we saw many hundreds of exoplanets. So that tells us that there are many planets around other stars. In fact, we have good reasons to think that every star in the sky has a planet or more. Think about that. If you consider that there are about 200 billion stars in the galaxy, that's 200 billion planets. There's a lot of opportunity there. Now, many of them are going to be far, so we're going to, with the James Hubble Space Telescope, we're going to try and focus on the ones that are close to us so that we can look more closely. Do they have atmospheres? What kind of temperatures are we looking for to find the promising ones? The first transit, what we call light curve, that the James Webb was one of the 5 images that was released. And I know that people love to look at really cool pictures. You can look that in the privacy of your own Instagram feed. I thought it would be nice to show you the data. Like, what is the cool aspect of these data points? So we found a planet with this lovely light curve. We found a size, and eventually we're going to look at the atmosphere of this particular exoplanet to find what kind of atmosphere do we have. We'll talk about that later. Doppler shift. Okay, so I'm not going to get into the details of the Doppler shift. I'm just going to say that a planet that's invisible makes a star move. So Jupiter, for example, is making the sun move. And if you have extremely sensitive equipment that we do now, you can measure a change in speed of a star down to the speed of a person walking. That's how good our instruments have gotten. 20 years ago, if you had told me, look, Jean, you really need to get into the exoplanet business, I would have said, look, I want to make a living. I want a research project that actually has some promise. In the time that I've graduated from grad school, the instruments have gotten so good, we've improved these measurements by a factor of 1,000. You can make noises. You can say, wow, that's cool. Subtlety is not what I'm looking for here. So this is the invisible planet that ridiculously is shown much bigger than the star. That is not usually the case. So we can't see the planet, but we do see the star in the middle moving. And based on very basic gravity, we can measure the mass of that planet. So if you're lucky to be able to measure both the size and the mass, you can get the density. And that means you can decide, is this planet like the Earth, made of rock, or is it like Jupiter? Because of a selection effect, most of the planets we have found so far are what we call hot Jupiters. They're close to their star, and they are made of gas, big. This is weird because we don't think that life is flourishing on a place like Jupiter. We think that Earth would be a better place. Okay, now direct imaging is perhaps the most easy to understand. It's the click and take a picture, right? If you Google exoplanets today, every picture that you're going to see is complete fiction. It is an artist's impression, with beautiful atmospheres. We don't have pictures that look like this. The best picture that we have so far of an exoplanet, James Webb is likely to change that, is something like HR 8799. You're seeing a picture in the center of a star that's been covered because the star is so bright it would totally outshadow the planets. And the little dots, those are the best pictures we have of exoplanets today. So those are planets that are tracking a star, and we're hoping eventually to be able to zoom in. These are fairly far, 130 light years away is reasonably far. With the James Webb Telescope, we can see Jupiter's within 100 light years. So this is a little out of our reach right now. So confirmed exoplanets I've already mentioned are over 5,000. Kepler is not working anymore, but it did many years of excellent work, 2,600. A machine that's working now started operating in 2018 tests, has over 2,200. What's fun about tests, and I had some pictures, but I thought it's better to describe this. It is taking every 2 minutes, it is photographing 20,000 stars. So it's creating those light curves. Every 2 minutes, it's taking a point. It turns out that stars can have dimming because there was a planet in front of it, but there are other reasons. There could be random objects, or there could be storms that could change the brightness of the star. So you really need a lot of data points to make it clear that it is a planet that's responsible for the dimming. We don't know how many James Webb. It could be, I'm guessing it'll be more than 2,000, but more to the point, it'll be able to zoom in to individual planets to find out what kind of atmospheres they have. After all, not all planets are going to be friendly to life. And it could be that it helps us find a biosignature. So proof, or as close to proof that we can get, that there is something living on that planet. So the question, of course, is natural. What planets are we looking for? And as I already said, we're looking for planets that are mostly solid, like Earth, and that are at the sweet spot, as what we call the Goldilocks zone. Not too hot, not too cold. In the solar system, there is certainly Venus, Mercury are too hot. So life is not likely to thrive there. Having said that, I'm putting a little asterisk. Some of you might remember there was some fuss about finding a chemical in the atmosphere of Venus, of all places. Nasty place, right? It rains acids, it rains poisons. The atmosphere is so heavy it would crush us, and it is the hottest planet in the solar system. And yet, even Venus might have some spot high in its atmosphere that's okay. Too cold in the outer reaches of our solar system, worlds would be so cold that chemistry as we know and love it would be very slow. We don't think very cold worlds would be good either. This is that habitable zone, what I called as the Goldilocks zone. That's where we're looking for. So we want a distance from the star that's not too close, not too far. That's not enough. You could be in the Goldilocks zone and still not have life. So the question is, how do we know Earth has life? If we were aliens on Mars, how would we know that Earth has life? And we're too far on Mars to see the structures that we made. People say that you can see the wall of China, but you can't actually, from the International Space Station. Some people would say, oh, it's because we've left debris. We have machines on Mars. Yes, that would be some sense, but whether they would know for sure that we sent them is not so clear. It turns out that the way you know that Earth has life on it is from two gases. We know it because we see, the aliens would see methane in the atmosphere of Earth and also oxygen. Why is that interesting? Methane and oxygen are so light that they would escape into space in a very short period of time. And the reason why we have methane is because it's constantly replenished. Constantly something is making methane on Earth. Who makes methane on Earth? Thank you. It is because cows fart. That's, and burp, I guess, is how aliens would know that the earth has life. After all, we live in the dairy states. It's good to know that it's the cows that are saying hello to aliens. It's that methane. Intriguingly, there is another planet in the solar system that has unexpected or ununderstood methane, and that's Mars. Now, it could be that's connected to the fact that um, it has underground gases that are escaping from volcanoes, but it could also be that methane has bacteria that are alive in the soil, and then those are releasing the methane. This is something still to be determined. After all, we do have lots of machines on Mars that are exploring that very question. So I did say that the Space Telescope, the James Webb Telescope, is going to tell us something about the properties of that atmosphere. And to do that, you treat the atmosphere like a prism. Light from a star is broken into all its colors, and we get something that's called a spectrum. And what's beautiful about chemistry is that each element has a signature, has a fingerprint that looks very different. So we would be able to identify methane or oxygen in a different atmosphere. And this is one of the graphs that the James Webb website includes. So a spectrum looks like this, what we say the rainbow. Some lines are missing. Pardon me. Oh, I pressed multiple buttons. Interesting. So these lines alone are very pretty for a chemistry textbook. But to do real research, you need to translate these dark lines into more detailed, high-resolution images that show all these signatures. This is hydrogen, for example. And one of the more quiet data points of the new release of the James Webb Telescope was this spectrum of water. We found water on a different planet. Now, water alone does not guarantee that there's life. After all, water is visible and available in the universe at large quantities. But it is promising that we find water in a different atmosphere of a different planet. So we're hoping that this is the first of many such signatures. And frankly, if you wanted my honest opinion, when we find life somewhere else, if we find life somewhere else, it's going to look like this. So I wanted to give you the preview to be looking out for it. When we see something, a signature of methane or oxygen in an atmosphere of a different planet, that will be what warms our hearts that in fact, there's likely other beings that are contemplating this beautiful universe just as we are. The picture, I imagine this you did see of the oldest picture. It depends on how you look at it. These are the youngest galaxies that we have ever found. And it could be that many billions of civilizations are looking at us right now, wondering what we're thinking. And with that, I'll very happily take questions, and I'll put in the plug of our programs. Please come to the planetarium. I can give a presentation, but I have stars in the planetarium, which is a whole nother experience, and you don't have to worry about mosquitoes or whether it is going to be raining. So I happily take your questions. Thank you for your attention.
Hey, thanks for coming here today. That's a great presentation. Is it possible that there is any other gas that any other type of organism could live on that we just don't know about yet, or that could support some other kind of life form?
Yes, of course. So carbon is an excellent starter, but it could be silicon. There could be other life forms. The fact is that it's hard enough to look for them in the chemistry that we really understand. This would be looking for other life forms, would be other chemistries, would be our second kind of plan. Yeah. Yes, of course. Thank you for your question.
Who is James Webb, and why did he have a telescope named after him?
James Webb was one of the administrators of NASA, and you probably heard there was some controversy about whether the telescope should be named after him. And it is a good reminder that when we look at things in hindsight, it's easy to point fingers about how we expect things to be done today. But of course, those were different times. And I just wanted to say that in the end, I think it was decided that James Webb lived in a homophobic society, and it doesn't seem like there's evidence that he specifically harmed a particular person. And it was decided that given that we're so far down this road, that we're going to keep the name. But as I said, it's easy in hindsight to point fingers, but we have to remember the context of the times that people lived in. And I say that, so I'm hoping that people will be kind to us. We did the best that we could under what we understood at the time. Thank you for your question.
Great, thanks for joining us. Two questions. One, a couple years ago, there was speculation that there was actually a ninth planet in our solar system. Very, very large, still unseen, but detected. Detected because telescopes had noticed objects near it leaning toward it, which means it was being pulled by its gravity. Any sense, any update or any speculation about that actually being a ninth planet out there, excluding Pluto?
The short answer is no. But let me explain. So there is a very large group of objects at the edges of the solar system that are called Kuiper Belt objects. And if we had discovered this in the opposite order, we had found the Kuiper Belt objects, many of them before we had found Pluto, then that's where Pluto would have been classified, no questions asked. But we did it the other way. We got lucky and we found Pluto first. So we didn't realize the much larger family that it's in. We'll talk about Pluto if you wish later. But it turns out that one of the people who was instrumental in finding the second Kuiper Belt object has subsequently found objects that possibly could be that ninth planet. But I think the understanding now is that if there was something as large as was originally hinted, then our spacecraft Voyagers would have changed their path as well. So it looks like if there is another, and I'm going to put planet in quotation marks because it's probably not a planet, if there are other objects, they're either much farther, or they are small and nearby. In any case, unlikely to be a planet, they could be members of the even larger objects, the Oort cloud, or they could be a larger Kuiper Belt object. So if I was a betting woman, I would say we're not going to find another planet in the solar system. Happily, we don't have to worry about that because there are plenty of planets elsewhere. Thank you for your question. You had another one.
The second question is, can you explain what's referred to as the red shift and the blue shift?
Yes. And if I had my favorite prop, which was a slinky, I could show it even better, but we're going to pretend that I'm holding a slinky. So light has two natures. You can imagine light as ping pong balls. Photon is the term. Photons come from the sky. You have a bucket, which is your telescope. More photons, better you can see. But light also, we discovered in the early 20th century, behaves like a wave. And you need both of these behaviors to explain what light does. So if you imagine that light is a wave, the wavelength, that is peak to peak, that length, is very much determined by the color that it has. So if you have light that's coming to you that's, say, a green color, it does its thing. And if you're in the lab and that color comes to you, you see green. However, if the object that's making that color is moving toward you, then the waves get squeezed and the color changes to the bluer part of the spectrum, and you say it is blue shifted. And if the star is moving away from you, then the slinky gets all stretched out and the color gets shifted to the red. And that's what we call redshift. When you're looking at very distant galaxies, they are redshifted because they are piggybacking on space as space expands. More coffee? It is a wonderful thing to think about the universe. Yes.
How do you raise funding for all of this work?
How do I raise funding, I ask? Thank you for asking. Are you asking funding for research in general or for what the planetarium does? In general. I've been thinking very hard about branding lately. That is not my training. I'm an astronomer by training. And I have come, you read things about how to advertise, how to promote things, how to promote services. And that's very noble. We all have needs that we're trying to meet. I think astronomy puts in a box some wonder. It's hard to sell that, but it is an inner need. It is an inner quest to understand where we come from, where we're going. Are we alone in this beautiful, large universe? And I think there's something intangible and wonderful about thinking I'm investing in wonder. Having said that, a lot of space research solves real problems on Earth. A lot of problems that we've solved to get people safely on an international space station and keep them healthy and going for many, many years tells us that we understand macular degeneration better because of how we treat it for people who are exposed for radiation. How do we, and I'm not going to get into colorful, you understand waste management in space is a real issue. And how we do that to recycle water is made it possible for people to use kidneys that would otherwise be not usable. So we have solved problems on Earth by thinking about how to live in space. And I think that's one of the wonderful things about when you start exploring big questions, you certainly think about outside the box and you're able to make life on Earth better. It also has made us think about our Earth as a special place. So one of the things we're responsible for is protecting Earth. There is no Earth 2.0. This is it for us. So we have to make sure that our planet is as healthy as we can and take whatever steps are required to ensure that we don't let Earth down. Yes.
Speaking of wonder, I'm wondering how one counts to 200 billion.
You don't count to 200 billion, but here's what you do. When we look at large numbers, and it's a very good question, how do you visualize a very large number? There are ways of doing this. In astronomy, we get pretty good at that. First of all, we start thinking in terms of numbers of zeros. We talk about orders of magnitude. We're not going to get lost in the details, significant figures of 2.364. No. How many zeros? Is it 10, 100, 1,000? that is useful because you realize, oh, the planetarium is 6 zeros away from the size of the Earth. Okay, that is something I can visualize. The other thing, of course, is you start looking at glasses of sand. If you imagine that a speck of sand is a star, you can get about 200,000 stars in half a liter of water. And that's a way of visualizing that. 20 million is a 5-gallon ice cream container. So these are good visuals to have, so then it becomes a little more concrete. Thank you for these questions. There's another one.
Can you tell us about your trip to the stratosphere? How did you get to go out there, and what was that like?
People ask me, how did you get to go to the stratosphere? There's several reasons. The first reason is that I worked on an infrared satellite, so it was understood that I would appreciate the work that's being done on SOFIA. The other reason is that I think because I run a planetarium that I have access to large numbers of people of the public, so it would be good for their public relations. The third one I like to remind especially students is I applied on time. It's very easy when you're busy to say, I don't have time for this deadline, and you just make it happen somehow, and you apply by the deadline. And I was chosen, a 1 of 24. The experience, so often people don't realize that the stratosphere is part of the atmosphere. So we live and breathe in the troposphere. That's where Mount Everest is. That's where commercial planes fly. The stratosphere is the next upper, so still very well within gravity. So I wasn't floating, and this was not the vomit comet. However, it is high enough that you are above 99% of the moisture in the atmosphere, which means you can see infrared light almost as well as the James Webb Telescope can. And the oxygen is very low. So we had our own personalized oxygen. If we did lose pressure, you would faint within a few seconds. Happily, this was not an issue, but we did have our own personal oxygen supplement with us. Now, they told us when we were learning how to operate it, they said that it's good for 15 minutes if you're not agitated and 5 minutes if you are. And I always wanted to say, if I need to use this, I'm probably agitated. In any case, it was a wonderful experience. We saw mostly star-forming regions, but also stars that are older. Stars have this beautiful thing that they recycle. When they die, they get all their material back into space, and those clouds sit there until a dying star's fast wind slams into it, gives gravity a little assist, and star formation begins again. That was thrilling. Probably for me, one of the most interesting aspects of the trip is that I got to see Northern Lights, the best I had seen by a long shot. We were flying at 60 degrees north, where the Northern Lights really were something very special. Yes, thank you for the question.
Thank you, Dr. Creighton. I visited the planetarium and have always enjoyed your programs. You mentioned that the universe is expanding, but I recall you saying it's not just expanding, but that expansion is accelerating. Would you explain?
Yes. This is actually one of the James Webb's missions. In addition to finding exoplanets, we're desperately trying to understand, why is the universe picking up the pace? We've known for a long time, for over 60 years now, a Nobel Prize was had by Wilson, it'll come to me, that the universe is expanding. We knew that. We saw the radiation from the Big Bang is going through us right now. We know that. We can measure that. Okay, that's nice. But in the last 20 years or so, we've realized not only is the universe expanding, but in fact, it's accelerating in its expansion, and we don't know why. We don't know what is the mechanism that makes that possible. So you might have heard the term dark energy. Dark energy is the catch-all phrase that says this is the mechanism, question mark, that makes the universe pick up the pace. And it could be that we don't quite understand gravity as well as we thought, and we need to tweak it. It could be more likely that it's a property of the vacuum. In either case, the James Webb Telescope is likely to be able to help us determining what is it that keeps the universe picking up its pace and its expansion. And that's something that is not, it's going to take a few months, maybe even a few years before that kind of data is available to us. That will stay tuned for another talk, I hope, at the Rotary, describing and exploring that interesting question. I saw. Thank you very much.